Good day, grade 12 learners. Welcome to today's physical sciences lesson. My name is Bongani Mabuya. This lesson is brought to you by the Northern Cape Department of Education in collaboration with the Pagama Research and Development. The topic of the day, it falls under the knowledge area called matter and material. We are going to look at the last topic of physics called photoelectric effect. That's what we're going to deal with. Photoelectric effect. This is the work of one of the greatest men to ever live in this world, whom we call Albert Einstein. So when we look at what is it that we're going to do, much of it is from the exam guideline. The exam guideline is specific. What is it that we must cover about this topic? Number one, we are going to define photoelectric effect. And all our definitions, we need to make sure that we define exactly the way the exam guideline has prescribed. Our definitions, they should be a duplication of the exam guideline. Number two, we are going to state the significance of photoelectric effect. Number three, we are going to define threshold frequency. Some of you call it cut-off frequency. We are going to define work function. And we are going to use the photoelectric effect equation to perform calculations. Then we are going to explain the effect of intensity and frequency on the photoelectric effect. That is the order of the day. Now, this topic started from grade 10. You did waves, particularly on the section called electromagnetic radiation. You had an opportunity to classify electromagnetic radiation according to the increasing wavelength or according to the increasing frequency. There was an introduction of photon, where you defined photon as the quantum of energy. And we had to perform calculations of E is equals to HF or E is equals to HC over lambda. Then, this is what I've just alluded to you. I'm going to give you 1 minute to deal with the base diagram. Now, let us look at your responses. When we deal with a multiple choice question, it is not a guess question. This question, it provides a detailed content that allows you to engage constructively and critically so. So, it is important that when we look at the multiple choice, we make sure that we understand the question carefully, we analyze it, and also we must deduce which formula must we use, which principle must we apply. A multiple choice will give you 4 options. 2 options are obvious distractors, and 2 options, they are correct, but 1 is more correct. you must always choose the option that is more correct. Number 1, a transverse pulse is a single disturbance A single vibration B, both A and B, neither A or B. So you can tell that C and D, they are obvious distractors. And then we are left with A and B. So A, it is a single disturbance. B, it's a single vibration. And the most correct answer would be A. So number 1, the correct answer is A. Let's come to number 2. The electromagnetic wave with the lowest energy, it will be, you go back to your grade 10 knowledge, and then when you look at how you were categorizing and classifying this electromagnetic radiation according to their increasing frequency, you'd find that radio wave has the lowest frequency but the longest wavelength, meaning that it has the lowest energy. So the correct answer is going to be D. Let's look at this question. The electromagnetic wave can travel through, you can see this one is a level 1 question. It travels through a medium. So you search for an option that has a medium. It can be A, it can be C, meaning that B and D, they are obvious distractors. So between A and B, the correct answer will be A. It travels through a medium. Let's move on. Now, the terminology that we use here in this topic, and precisely I chose the definitions that you can expect in your upcoming examination. These are the only definitions that the examiner will ask you about photoelectric effect. The first one, the examiner can require you to define photoelectric effect. Sometimes the examiner does not say define, but the examiner would say name the phenomenon. So if you see the word phenomenon in question 10, just make sure that you write the correct answer, which is photoelectric effect. They won't ask you what do you understand by the term phenomenon. If you see phenomenon in question 10, your answer must be photoelectric effect. If they say define the term photoelectric effect, you must use the exam guideline of 2021 definition that says a photoelectric effect, it's a process whereby electrons are ejected from a metal surface when light with suitable frequency is incident on that surface. With this definition alone, we have covered the whole topic. It is the process whereby electrons are removed from where? From a metal surface. By what? By light, and that light must have what? Enough energy, enough frequency to remove that electron. Number 2, threshold frequency. We are talking about the minimum frequency needed to eject electrons from a certain metal surface. So all the metal surfaces have different threshold frequencies. Like for instance, zinc has the lowest threshold frequency to eject electrons, meaning that it is more easier to eject electrons from a zinc metal than a sodium, than magnesium, than copper or cobalt. Work function, it is the minimum energy needed to emit electrons from the metal surface. So the difference between threshold frequency and work function, it is the word energy, it is the word frequency. If we say threshold frequency, then you will say it is the minimum frequency. If we say work function, then you will say minimum energy needed to eject electrons from a metal surface. Photon is a grade 10 concept. It is the quantum of energy. It is packets of energy. And we are saying that one electron can absorb one photon. Photoelectrons, these are the electrons that will be emitted from a metal surface. So more emphasis should be on these top three definitions. The examiner will require you to define one of the three definitions. If you look at the question papers from 2014 up until June 2025, there is one of these concepts as a definition. So already we are having 2 marks. We are in it with 2 marks. Now, let's look at the exam guideline. So let's make sure that we always define concepts based on the exam guideline of 2021. These are our weapons. For us to do well in physics, we know that our equipment or our tools, they are the exam guideline and the data sheet. These are our tools. What does the exam guideline say about this topic? Photoelectric effect. Number 1, you should be in a position to define or to describe photoelectric effect as what? As the process whereby electrons are ejected. That's what photoelectric effect is. We are saying that photoelectric effect is a process whereby electrons are removed. Where are they removed? They are removed from a metal surface. By what? By light. And this light, for it to remove the electrons, it must have enough frequency, it must have enough energy to eject electrons from a metal surface. So that is the phenomenon. It's photoelectric effect. The exam guideline, it continues also to say we must define the threshold frequency. So that is an extension. Remember we said the light that must eject electrons, it must have enough frequency. So what is that frequency? Threshold frequency. What is threshold frequency? It is the minimum frequency needed to eject electrons from a certain metal surface. The threshold frequency for zinc, it is not the same with the threshold frequency for sodium. It is not the same with the threshold frequency for silver. It is not the same with the threshold frequency for cobalt. So each metal has its own threshold frequency. So the minimum frequency needed to eject an electron from that specific metal surface is called threshold frequency. And remember, we said this light that shines on the metal surface must have enough frequency, threshold frequency. It must also have enough energy. Now we are talking about what? Work function. What is work function? It is the minimum energy needed to eject electrons from a metal surface. And then the formula for work function is work function is equals to Planck's constant multiplied by threshold frequency. So these are the 3 terms that we must make sure that we are ready as we approach our exam. Then the exam guideline is saying we must perform calculations using the formula of the photoelectric effect. Energy is equals to work function plus EK max. Maybe an emphasis there is to say make sure that you copy the formula the way it appears from the exam guideline. So when we say energy, it's E is equals to W subscriptive 0. That subscriptive 0, it indicates that we are dealing with work function. So if there's no W subscriptive 0, then that becomes work done. So you see the importance of writing the subscriptions because they provide the meaning to the expression. So it's W with a small 0 plus EK and put small max. Let's copy the formula the way it appears from the exam guideline. The formula for the work function is Planck's constant multiplied by threshold frequency. EK max is 1/2 multiplied by the mass of electron multiplied by V squared max. Then we are going to explain the effect of intensity. When we talk about intensity, we are talking about brightness and frequency on photoelectric effect. The last one, we are going to state that the photoelectric effect demonstrates the particle nature of light. Why are we saying this? Because they'll ask you in the exam, what is the significance of photoelectric effect? The answer to that is in the exam guideline, to demonstrate the particle nature of light. So the reason why we are doing this topic, it is to prove that light has a dual nature. When it wants, it can behave as a wave. When it wants, it can behave as a light. Now, let's get into it. Much of what is in this presentation, it has been discussed before. But maybe we need to appreciate the man that provided this breakthrough. Before 1905, scientists, they believed that light is a wave. There was a general consensus and an overview and an accepted opinion at that time that light is a wave. We've seen great scientists who proved that light is the wave. For instance, when we look at the work of Eugene, as he came with Eugene's principle, where he said that if you put two apertures and then you shine the light will travel. When it hits the apertures, it will bend around the aperture, which indicates that light, it will continue to shine and travel in the medium. So that was a demonstration that light is a wave. And a lot of people at that time, they had accepted that light is a wave. The last person to even confirm that light is a wave is a man called Max Planck, who came with a constant value of h, which is a constant value called Planck's constant. And the value of it is 6.63 times 10 to the power negative 34. He's one of the men that proved that light is a wave. Then in 1905, a man called Albert Einstein committed an experiment to prove that it is not enough for us to say that light is a continuous wave, but light has a dual nature. It can act as both a wave and a particle. So Albert Einstein then came with a theory called photoelectric effect. How did he do it? He demonstrated a simple experiment. He took a metal plate, and then what he did, he took two different lights. The other one was visible light, the normal light that you use at home. The other one was ultraviolet radiation. Now, when he used the visible light on the metal plate, there were no electrons that were removed from the metal surface. But when he changed the light and he used ultraviolet radiation, remember, ultraviolet radiation has high frequency. In fact, it has one of the highest frequencies. So when he used the ultraviolet radiation, he shined the ultraviolet radiation on the metal surface, and then electrons were ejected. Because what is photoelectric effect? It is a phenomenon, it is a process whereby electrons are ejected from a metal surface when light shines on the metal surface. And that light must have enough frequency and enough energy. So this is a typical demonstration of photoelectric effect, that if the light with high or with suitable frequency is incident on the metal surface, it will cause the electrons to be ejected off. Furthermore, he committed an experiment. What did he do? He took two metal plates. The cathode, here is our cathode, and the anode. And then he placed an ammeter. Now, he increased the intensity of light. He used an ultraviolet radiation. As the light was shining on this metal plate, what happened? The electrons, they were ejected. They were moving from one plate to another. We are seeing the electrons, they are moving from cathode to anode. And when electrons move from cathode to anode, then we are going to have what we call what? Current. What is current? Current, it is the rate of flow of these electrons. The more they move, the ammeter reading increases. So that was a demonstration of photoelectric effect, that when the light shines on the metal surface, electrons will be ejected from the metal surface. Now, furthermore, he was not done. He said, let me give you a different experiment. He did what we call a photoplate. He had an electroscope, a simple electroscope that he established, a zinc plate connected to a metal rod, and then this metal rod was connected to gold leaf. That's what he did. And then he made sure that the zinc has electrons, meaning that it is negatively charged. Let's start from the red light. The red light is the visible light. Remember we said he used two lights, visible light and ultraviolet radiation. Now, when the zinc has negative charge or it has excess electrons, because it is connected to the rod will also be negatively charged. These electrons will go to the gold leaf and make gold leaf to be negatively charged. What does science say? Like charges, what do? They repel. So we'll start by observing the gold leaf moving further and further away from each other. So that's what was happening. The gold leaf, you can see the distance there. It was moving apart from each other. Now, when Albert Einstein then shined the visible light, nothing happened. Nothing. And I'm sure people, they were laughing there that, no, we got you now. Now we got you. Then he said, no, it's fine. Let's change the light. And then he used what we called ultraviolet radiation. Same procedure. We put the electrons to the zinc. The zinc will have excess electrons. Because the metal rod is connected to the zinc, the electrons will flow to the metal rod and they will flow to the gold leaf. This will cause the gold leaf to do what? To repel, because the other side will be negative and the other side will be negative, and we are saying like charges, what do? They repel. They're like, okay, it's fine. When he shone the ultraviolet radiation on the zinc plate, something started to happen. They observed that the gold leaf, they started to move closer and closer to each other. Why was the gold leaf moving closer and closer to each other? It is because the electrons, they were ejected from the metal surface. The more you are shining on the zinc was losing the electrons and becoming less negative, less negative, less negative, meaning that the rod was becoming less negative and one side of the gold leaf was becoming less negative. Now, what does this mean? Unlike charges, what do? They attract each other. What brought the gold leaf closer? It was due to the fact that the other side was becoming positive while the other one was negative, because unlike charges, what do? They attract each other. That was a perfect demonstration of photoelectric effect. Then, this is what we have explained to say that as you use different lights, then that's when we observe photoelectric effect. From there were serious statements that were made. Then Albert Einstein concluded that this photoelectric effect, it is demonstrating the particle nature of light, meaning that one electron can absorb one photon. If that one photon has enough energy, then that electron will be ejected. So that's why then we are bringing in the formula for NH. NH is equals to HF. But here are the conditions now. There are three. If the energy is less than the work function, remember what is the work function? It is the minimum energy needed to eject electrons from a metal surface. So if the energy is less than the work function, then photoelectrons will not be ejected. That light will not have enough energy to remove the electron. Let's look at scenario number 2. If the energy is equal to the work function, what will happen? The electron will absorb the photon with enough energy and be removed from the metal surface, but it will not move, meaning that the kinetic energy will be 0. Let's look at condition number 3. If the energy is greater than the work function, then we are going to have excess energy that will be absorbed by the electron. Not only the electron will be ejected, but the electron will have maximum kinetic energy. So that is why then we ended up having the formula for photoelectric effect as energy is equals to work function plus EK max. We can expand on this formula. If you are given frequency, you can say energy is equals to H multiplied by frequency is equals to the formula for work function is Planck's constant multiplied by threshold frequency plus EK max, which is 1/2 mv squared. If you are given the wavelength, then your energy will change. Instead of saying HF, you are going to say energy is equal to HC over lambda is equals to work function, which is H threshold frequency plus 1/2 mv squared. So these two scenarios, they are based on what you are given from the exam. If you are given frequency, you move with frequency. If you are given wavelength, you run with wavelength. Let's look at the graphs. So when we look at the graph, I'm going to mention just two important points. These are the ones. You can see this is a graph of kinetic energy against frequency. So the lowest point that the graph can reach, that is our work function. Remember, our y-axis is energy. The lowest point that the graph can reach, that is our work function. Because we'll ask you, what does that point represent? It represents the work function. And then here at B, where it is 0, that's where we are having our threshold frequency. That's the minimum frequency needed to eject electrons from a certain metal surface. And then they can also ask you, what does the gradient here represent? Then you'll tell us what the gradient represents. We can have a comparison of two metals here. We can have metal 1 and metal 2. Maybe a question that I might ask is, which one will need more frequency to eject electrons from a metal surface? And your answer here, it will be metal 2, because metal 2 will have a higher threshold frequency as compared to metal 1. Now, I'm going to allow you to engage with this multiple choice question. Now, let's look at this multiple choice question. We are saying a multiple choice is not a guess activity. That your grandmother's name is Christina, therefore the answer is C. We can't work in that fashion. Let's make sure that we read the statement, we understand the statement. Which one of the following provides that light behaves as a particle? Remember, that is the importance of photoelectric effect. It is to demonstrate the particle nature of light. A, light can be diffracted. Remember, that is Eugene's principle, that is a wave. So that one can be correct. 2, light is refracted by a triangular prism, that is continuous wave. So B cannot be correct. D, the speed of light decreases when it travels from air to glass. You know that is factually incorrect. The speed of light is always 3 times 10 to the power 8 meters per second. So we're left with one obvious option, which is C, that light ejects electrons from a certain metal surface. Let's do 1.2. Right, 1.2, the question is saying a photon of light of energy is 2x is shown onto a metal surface with work function x joules. Which one of the following correctly represents maximum kinetic energy? So I think we must write the formula. Work function energy is equals to we have to write the formula here. Energy is equals to work function plus EK max. We are told that energy is 2x, and we are told that work function is x. So we want to know which one best describes EK max. When you transpose this to the other side, it will be 2x minus x is equals to EK max. Therefore, EK max is going to be x joules. Then you look for an option that is x joules, and that option will be C. The option will be C. You see? So it is important that we put the content when we do a multiple choice. Then, here is a question here, it's question 10. When light of various frequencies is incident on the metal cathode of a photocell, photoelectrons are emitted from the surface of the cathode. We're having the graph that will show the relationship between EK max and wavelength. Let's look at the graph. Here is the graph. Our y-axis is EK max. So whatever value that you see here, it's 6,0 times 10 to the power negative 19 joules. Whatever value that you see on our x-axis, you can see here is 3,8, but you must say, or is 4, times 10 to the power negative 7 meters. So it is important to interpret the graph very well and understand what is it that you are given on your y-axis, what is it that you are given on your x-axis. Here is the first 3 questions. Use the graph to determine the maximum kinetic energy of the emitted photoelectrons when the wavelength of the incident light is 1,0 times 10 to the power negative 7 meters. What relationship between the maximum kinetic energy of the emitted photoelectron and wavelength of the incident light can be deduced from the graph? Define the term work function. I did say out of the 3 definitions, you will get 1. 10.4. Use the graph to calculate the work function of the metal used as cathode of this photocell. 10.5. Calculate the maximum kinetic energy of the emitted photoelectron when the wavelength is 0,5 times 10 to the power negative 7 meters. I'm giving you 13 minutes to deal with this question. The first question required us, 10.1, to use the graph to determine the maximum kinetic energy if the wavelength is 1 times 10 to the power negative 7. So you're supposed to come here and check when the wavelength is 1 times 10 to the power negative 7. I think this was the point. And then you must count the intervals, and you're supposed to get 11,6 times 10 to the power negative 19 joules. And then 10.2, what relationship can be deduced from the graph? When you look at the graph, you can see here, the higher the kinetic energy of photoelectrons, the lower the wavelength. So that's what we can deduce, is that the wavelength increases as maximum kinetic energy decreases. You must be specific from the graph. As you increase the other one decreases. The next question, define the term work function. We must provide the definition the way it appears from the exam guideline. Work function is defined as the minimum energy needed to eject electrons from a metal surface. Then 10.4, the question required us to calculate the work function. So we can have 2 options there. We can use the formula E is equal to HC over maximum wavelength. Or we can use the one that says E is equals to work function plus EK max. What is important here? We know that at maximum wavelength, our EK max is 0. And our maximum wavelength is our work function, which is HC over maximum wavelength. So work function then can be 6,63 times 10 to the power negative 34, and then multiplied by the speed of light, which is 3 times 10 to the power 8, divided by maximum wavelength. Maximum wavelength is the minimum frequency, is the minimum energy. Then you'll get your answer is 4,06 times 10 to the power negative 19 joules. The next question then said calculate EK max. You're given the point of reference there when the wavelength is 0,5 times 10 to the power negative 7. You must write the formula as original as it is. Energy is equals to work function plus EK max. Then you can expand on energy HC over lambda, which may be 6,63 times 10 to the power negative 34 multiplied by speed of light, which is 3 times 10 to the power 8, divided by the given wavelength, which was 0,5 times 10 to the power negative 7, is equals to, when the wavelength is 0,5 times 10 to the power negative 7, our work function is 4,06 times 10 to the power negative 19 plus EK max. You solve, then your EK max will be 3,57 times 10 to the power negative 18 joules. Activity 2. A group of learners conducted an experiment to determine the relationship between the inverse of wavelength and the maximum kinetic energy. So that graph represents that. Our y-axis is EK max, our x-axis is EK max, which is our inverse in the wavelength as well. Here are the set of questions that you must respond to, and we are giving you 10 minutes to respond to them. Then we can look at feedback. 10.3, the brightness of the light is now increased. What effect will this have? And your answer will be, it will remain the same. Why? Because the gradient is equal to the product of the Planck's constant. Or someone can say the gradient from the graph represents the Planck's constant. And then 10.3.2, draw the graph. So this is what we're expecting for you to show us that EK max will be constant. EK max will be constant. Just to get 3 marks, it will remain the same. Then here is your homework section. Let's make sure that we do this homework. These are the questions to the scenario. And then I will leave you with the quote of the man who came with this content that we appreciate today. His name is Albert Einstein. One of his greatest quotes, he said, and I quote, "The greatest thing about big ideas is being able to share them." As we do revision, let's have peer collaborative revision programs. Form small groups and share this content. Discuss this content. More than anything, it is about you, not the teacher now. Let's make sure that we engage actively so with this content. Continue to attend these revision sessions because they are meant to help you. We want you to be the best. See you next time.